Hello friends, welcome to my YouTube channel, Raja Gogasikotar 1719. Imagine an object so dense that one spoon of it weighs more than Mount Everest. An object born from the violent death of a giant star. An object spinning hundreds of times every second. This is not science fiction. This is real. This is a neutron star. Today, we will take a journey step by step to understand what a neutron star is, how it is formed, and why it is one of the most terrifying and fascinating objects in the universe. 1. The life of a star. Before a neutron star is born, before explosions, gravity, and destruction, there is only silence. Far away in the universe, inside massive clouds of gas and dust, something incredible begins. These clouds are called nebulae, the cradles of stars. Over millions of years, gravity slowly pulls this material together, bit by bit, atom by atom, until pressure and heat rise to unimaginable levels. And then, a star is born. At the heart of this newborn star, a powerful process starts. Nuclear fusion. Hydrogen atoms collide and fuse, creating helium. In this process, an enormous amount of energy is released. This energy pushes outward, fighting against gravity. Gravity pulls inward, trying to collapse the star. This perfect balance keeps the star alive. For millions, sometimes billions of years, the star shines, lighting planets, shaping galaxies, and ruling its corner of space. But this balance is fragile, because no star lives forever. One day, the fuel at the core begins to run out. The energy weakens, the pressure drops, and when gravity finally wins, the life of the star enters its final chapter. 2. When a massive star dies. Not all stars die quietly. Some stars are born massive, many times larger than our sun. They burn brighter, faster, and more violently. Inside these giant stars, nuclear fusion continues beyond hydrogen. Helium turns into carbon, carbon into oxygen, oxygen into heavier and heavier elements. But there is a limit. When iron forms in the core, fusion no longer produces energy. Instead of releasing power, it drains it. The star is now living on borrowed time. With no energy pushing outward, gravity takes control. The core collapses inward in a fraction of a second. Temperatures rise to billions of degrees. Atoms are crushed together. The collapse becomes unstoppable. Then the core suddenly rebounds. A shockwave tears through the star, ripping it apart in a catastrophic explosion. This explosion is called a supernova. For a brief moment, the star outshines an entire galaxy. Matter is blasted across space at incredible speeds. Everything the star once was is scattered into the universe. But the story does not end with destruction. Hidden inside the wreckage, something extraordinary is being born. 3. Birth of a neutron star. After the supernova fades, after the universe falls silent again, the star's core remains. What is left behind is not ordinary matter. The collapse is so extreme that the laws of nature are pushed to their limits. Inside the core, gravity becomes overwhelming. Electrons are forced into protons. Two particles merge into one. A new particle is born, the neutron. In less than a second, the entire core transforms. Atoms collapse. Empty space inside matter disappears. The core becomes a single, ultra-dense object, a neutron star. It contains more mass than our sun, yet it is squeezed into a sphere barely 20 kilometers wide. This is not just a star. It is a giant atomic nucleus floating in space. Gravity on its surface is so powerful that nothing behaves normally anymore. time slows, matter changes, physics itself is tested. At this moment, the neutron star is born not with light, but with unimaginable density and force. And this newborn object is one of the most extreme creations the universe has ever made. 4. The incredible density. To understand a neutron star, you must forget everything you know about matter. Because here, density reaches its absolute extreme. A neutron star packs more mass than the sun into a sphere no wider than a small city. Imagine taking Mount Everest and crushing it into the size of a sugar cube. That is the density we are talking about. Just 1 teaspoon of neutron star material would weigh billions of tons on Earth. Atoms no longer have space inside them. Electrons are gone. Nuclei are pressed together so tightly that matter becomes something entirely new. This is degenerate matter held up not by heat, but by the quantum pressure of neutrons themselves. Gravity here is so strong that a person would be flattened instantly, pulled thinner than a sheet of paper before even touching the surface. Mountains cannot grow tall. They rise only a few millimeters before collapsing under their own weight. A neutron star is not just dense, it is the edge of physical possibility. One step closer, and even this resistance would fail, turning the star into a black hole. 5. Spinning faster than imagination. When a massive star collapses, it doesn't just shrink, it spins. As the star's core becomes smaller and denser, its rotation speeds up faster and faster, driven by the same physics that makes a spinning dancer accelerate when pulling in their arms. What was once a slow-turning giant becomes one of the fastest spinning objects in the universe. Some neutron stars rotate hundreds of times every second. That means in the time it takes you to blink, the entire star has already completed dozens of rotations. This spin is so precise, so stable, that neutron stars rival atomic clocks. But the spin does more than just amaze. As the neutron star rotates, it releases intense beams of radiation from its magnetic poles. When these beams sweep across space and pass by Earth, we detect them as rhythmic signals. Tick, tick, tick. These cosmic lighthouses are called pulsars. Each pulse is a heartbeat, a signal sent across the galaxy from an object no larger than a city, yet more powerful than stars, millions of times its size. 6 MAGNETARS, the monsters of magnetism. Some neutron stars are dangerous, others are terrifying. Among all known objects in the universe, there exists a class of neutron stars with magnetic power beyond comprehension. They are called magnetars. Their magnetic fields are not just strong, they are the strongest magnetic fields ever discovered. Trillions of times more powerful than Earth's magnetism. These fields twist space itself and tear atoms apart. On a magnetar, the crust of the star is under constant stress. When that crust cracks, the result is a starquake. In a single moment, a magnetar can release more energy than our sun will emit in hundreds of thousands of years. From thousands of kilometers away, its magnetic force could erase digital data, disrupt electronics, and damage living cells. Up close, survival is impossible. Magnetars remind us that the universe does not care about life. They are raw power nature, unleashed without mercy. And yet, they are still only one form of the neutron star family. 7. When neutron stars collide, far across the universe, 2 neutron stars orbit each other in silence. Locked together by gravity, they spiral closer and closer over millions of years. As they move, they shake the very fabric of space and time. These ripples travel across the universe as gravitational waves. Then, in a final instant, the two neutron stars collide. The impact releases more energy than billions of stars combined. Space flashes with a brilliant burst of gamma rays. Matter is torn apart and rebuilt in ways that cannot happen anywhere else. In this cosmic explosion, the universe forges its rarest treasures. Gold, platinum, heavy elements that cannot form inside normal stars. Every ring, every coin, every piece of gold you touch may have been born in a neutron star collision billions of years ago. This is not just destruction, it is creation. From the death of stars, new matter is born, shaping planets, worlds, and eventually, life itself. The universe remembers these collisions, writing their story into space and time. 8. Neutron star versus black hole. There is a thin line in the universe between survival and total collapse. That line separates a neutron star from a black hole. Both are born from massive stars. Both begin with a supernova. But their final fate depends on one thing mass. If the remaining core is heavy, but not too heavy, neutron pressure fights back against gravity. The collapse stops. A neutron star is formed stable, dense, and incredibly powerful. But if the core is just a little more massive, gravity becomes unstoppable. No force can resist it. Not atoms, not neutrons, not even the laws of physics as we know them. The core collapses endlessly, creating a black hole, a region where space and time break down. A neutron star is the universe's last defense. The final structure that can exist before reality itself gives up. In this way, neutron stars are not failures, they are survivors. They stand at the edge of infinity, holding themselves together against impossible odds. 9. Why scientists study neutron stars. Neutron stars are not just cosmic wonders. They are keys to understanding the universe. Inside them, gravity reaches extremes that cannot be created on Earth. Matter exists in forms that scientists have only theorized. By studying neutron stars, researchers test the limits of physics, from Einstein's theory of relativity to the strange rules of quantum mechanics. Neutron stars also help us understand how space and time behave under immense pressure and how the universe creates its heaviest elements. Their precise rotations allow scientists to detect gravitational waves, measure cosmic distances, and explore the hidden structure of the galaxy. In many ways, neutron stars are natural laboratories, silent, distant, yet filled with answers to the universe's biggest questions. Every signal they send brings humanity one step closer to understanding where we came from and how the cosmos truly works. 10. The cosmic message. Neutron stars are not just objects in space. They are stories written in gravity, density, and time. They are born from destruction, yet they create the very elements that shape planets, oceans, and life itself. Every neutron star reminds us that the universe is both cruel and creative, violent and beautiful, chaotic and precise. They exist at the edge of what is possible, holding themselves together against forces that try to tear reality apart. When we study neutron stars, we are not only learning about space, we are learning about existence. Because the atoms inside your body were once forged in stars and perhaps refined in explosions far more powerful than anything we can imagine. In understanding neutron stars, we understand our place in the universe as small, fragile, yet deeply connected to the cosmos itself. And as long as neutron stars continue to spin, in the darkness of space, the universe will keep whispering its secrets to those who dare to listen. So friends, this was today's amazing information. Hope you liked this video and learned something new. If you found the video interesting, don't forget to like, share, and subscribe. See you again in the next video with another new and surprising thing. Until then, stay happy, stay healthy, and stay tuned to learn. Jai Goga Sikotar Malam.